Today, I want to go over multiplying monomials. So a monomial is a single term. So let me kind of highlight that. This is a term. And the way that you know you're dealing with a single term, it is a single term because it's not adding or subtracting other terms. So if you notice, there's no other plus or minus symbols around. And within that single term, you might say, well, what's up with the 3 and the x squared and the y? Those are not separate terms. These are each factors. So this is a factor of 3. This is a factor of x squared. And this is a factor of y. So a single term can have many factors, and the defining operation between factors would be multiplication. So usually in algebra, the way you'll see a term is it's a term that has numbers, negative numbers sometimes, variables, but as long as all those things are just multiplying to each other, we would just call that a single term of many factors. Let's just look at a pretty simple example of some algebra you may have seen before or are currently going over. Now, I know before I mentioned that this could be a single term, but if I were to group them up and say, okay, what's an x times an x? Technically, you can think of that as two terms multiplying each other, but this will become a single term after we're done multiplying. So let's just start with that. What is x times x? So x times x is known as the variable expression x squared. And that shouldn't be a very difficult product. However, this could get confused, and I'm not going to spend a lot of time in this video discussing this separately, but how does it differ from x plus x? Well, in x plus x, you're adding two terms of x, and you just count how many x's you have. So 1x plus 1x is 2x. So just moving forward, and in case this is something you find trouble with, remember when you multiply x times x, that creates a variable term known as x squared. And when you're adding x's, you're just counting how many you have, right? 1x plus 1x makes 2x's. So moving forward, what if you had to multiply, let's say, x to the third times x to the fourth? So in algebra classes, you may have learned some rules for multiplying powers. And this video is not dedicated to that. But I just kind of want to take the time to help you understand, well, what do you do when you multiply x to the third times x to the fourth? Well, let me kind of color code this. So let me actually rewrite x to the fourth in green here. Okay, so if we had to do x to the third times x to the fourth, in black here, let me re-represent what x to the third means. X to the third power means x times x times x. Now, if we want to multiply by x to the fourth, I'm going to highlight those factors in green. X to the fourth has 4 factors of x. So if you were to just write out the expansion of these powers, you can just count how many x's you're multiplying, and we have 3 black x's and 4 green x's. So if you just count how many you have, the resulting product is x to the 7th. So again, this video isn't devoted to this, but one of the rules of multiplying powers is if you have the same base, right, x to the third times x to the fourth, you just add the 3 and the 4. But I wanted to illustrate that. And again, if you don't know these rules I'm talking about or haven't messed much with powers, I wouldn't worry about that too much because I'll be expanding the powers that I work with. Now, where can this get a little more complicated? Hopefully up to this point, this might be familiar territory. But here's where you might start to struggle. So let's say I have a monomial 4x, and I want to multiply, and I'm going to color code this so I can keep my factors separate. 3x squared. What would this equal? Well, we can rewrite this as an expansion of all of the factors that are being multiplied. So if you take a look at the two monomials being multiplied, this is a 4 times an x, and this is a 3 times an x squared, right? So if I were to rewrite the factors out, we have 4 times x, right? Those are the two factors from the 4x monomial, times, and I'm going to write this completely out, including the x squared, in terms of its single factors times 3 times x times x. So we have 4 times x times 3 times x times x. That's the same question. Now, from here, though, you could be a little confused as to, well, what next? How am I allowed to multiply this? Like, how do I multiply 4 times x? Well, thankfully, the operation of multiplication is commutative. It is commutative, meaning I can actually rewrite the order of my factors in my expression because they're all multiplying. So if you notice here, I could actually start by saying 4, but then I can actually switch over to bring my 3 factor next to the 4 because I know I can multiply numbers times numbers. And then here comes the x that used to be next to the 4. I mean, it doesn't really matter which one I'm talking about, but I'm color coding to show you which one's which. Not that it really matters, but, and then I'm still going to end my expression with the 2 x's there. So if you just look, I switched the places of the x factor here with the 3 factor right next to it. And this is completely legal in the operation of multiplication. So now we just multiply factors that we know we can multiply. We know how to multiply 4 times 3. That's on our times tables. That's 12. And similarly, we have 3 factors of x, which we use a power to re-represent multiple x's in a term that are multiplying. So x times x times x is x to the third, and we can just write it just like that. So 4x times 3x squared is 12x cubed, or x to the third power. All right, let's look at another one. We can ramp it up a little bit. So what if you had the monomial negative 9x squared y times another monomial 2xy to the third? And again, just to help myself and to help you if you're watching and this already looks a little intimidating, let me actually swap out that monomial with a different color. Write out my factors. You can kind of color code and know which factors belong to which expression from the beginning. All right, so let me write this out on the bottom here. All right, so we have a negative 9, right? That's the leading factor there, times, and x squared is x times x, and then times y, right? So that's negative 9x squared y. Then we're going to multiply the next monomial, which I'm going to break it up into its individual factors, 2 times x times y times y times y. Now I understand if you're in an algebra course and you're working with problems that have higher exponents, it would be more useful if you knew some of your exponent rules. However, this video is just dedicated to making sure you understand what's happening, behind the scenes when you're using those rules. So I'm choosing exponents that are pretty small, but you might have to review your exponent rules on your own or in a different video. All right, so we have this. Now, because from before, I can commute my factors, right? It's commutative property. I can go ahead and rewrite factors I'd like to multiply first, and then kind of group up my factors the way that I would like to multiply them. So I'm going to start with the negative 9 first, and then I'm going to multiply by the 2, right? Because I know how to multiply numbers times numbers. Well, what would come next? Well, then I have 2 x's in black from the first expression, and then the x in red. So I'm going to multiply my 2 x's next, and then times the red x. Again, it doesn't really matter which x's we're talking about, but as long as we have the correct number, right? We do have 3 factors of x. And then I could just count. How many factors of y do I have? I have 4. So let me just make sure I put my color coding to keep things straight here. I have a y from the first monomial, but then the rest of them all come from the second monomial. So this kind of keeps it all organized, and you can kind of see where I took different factors and put them in different places because of the commutative property. Okay, so from here, I can just multiply as I go. So a negative 9 times a 2 is negative 18. Remember, multiplication is independent of value, right? A negative times a positive is a negative, right? The value of the numbers don't matter, right? It doesn't matter that 9 is bigger than 2 or anything like that. All right, and then I have 3 factors of x. So an x times an x times an x is x cubed. And then if I just count my factors of y, I have y times y times y times y. I think I said the right number, 4 of them. And that would be negative 18x cubed y to the 4th power, and that's my product. We'll end with a monomial times another monomial. I'll color code this one with red. And another monomial. This one will be in green here. And what if you had to multiply and simplify this expression? So I'm going to do it same thing I've done in my previous examples. So I have a 4xy, so I'm going to write that out as 4 times x times y. And then in red, I have a negative y squared. So how do we deal with a negative y squared? So does a negative belong to the y squared, to the z? Which factor does it belong to? Well, what you may have seen in previous, again, if you've ever taken pre-algebra or algebra or any course that uses variables, another way to think about negative y squared z is a negative 1 y squared z. And the reason why that's useful to consider, instead of calling it just negative y squared z, and now we can call it negative 1 y squared z, is we can actually use negative 1 as its own factor. So this would be negative 1 is another factor, along with my y times z. So any monomial or any term that has a leading negative, you could factor out a negative 1, right? That negative 1 is a factor of the expression. And then lastly, since the 2 is leading and it has a negative, we'll just also call that a negative 2. And then separate the factors x and y. So kind of a lot going on here. And I'm going to try to keep my color straight, but here we go. First I'm going to do is group my numerical factors. So I'm going to have 4 times my negative 1 from the red expression, and then times my negative 2 from the green expression. So those are all my numbers taken care of. Then I have x and y and z as 3 separate variables. So I'm going to group up my x factors. So I have a factor of x from my first expression, the first monomial, and then I have an x from my green expression. Okay, let's keep things straight here. And then I can go to my y's. So I have a y in my first monomial. I have 2 y's in red, so 2 y's in the red. And then I do have another y in the green here. And then I only have 1 factor of z, and that's in red. So just to keep up with my color coding, I think that'll do it. So yeah, it can seem a little overwhelming to like rewrite it like this, but I really just want to exemplify that all I'm doing is taking exactly what I'm seeing and rewriting them in a way, or rewriting the expression in a way where I'm grouping up the factors that I know how to multiply together. Like I know how to multiply numbers times numbers. I know how to multiply x times x, or y times y, etc. So here I go. So in black, we'll just go ahead and take care of the numerical factors. All right, so 4 times negative 1 times negative 2. A negative times a negative is a positive. So this is a positive 8. All right, we'll take care of the x's in red. So an x times an x factor makes x squared. In green, I'll take care of my y factors. So a y times a y times a y times a y is y to the 4th. I'm just counting them, And then lastly, z. Don't have to do anything fancy, but there is a single factor of z, so z. So my final expression would be 8x squared y to the 4th z. And that's how you multiply monomial expressions.